Alright, here we're going to look at a problem that asks us to find the relative extreme of a function, and then what we're going to do is we're going to list them and classify whether they're a relative mean or a relative max, and then we're going to sketch the graph of the function. So firstly, we need to find out when the derivative of the function will be 0, because at this point is where the derivative could conceivably change sign. So that's the first step. So we're going to find our derivative, in this case f prime. This function is simple because we have the derivative of a third of x cubed is going to be x squared, and then whenever we have plus a half of x squared, the derivative will be just x, and then minus 2. And what we're going to do now is we're going to find the point where the derivative is either 0 or undefined. Now, the function is a polynomial, therefore the derivative rather is a polynomial, so it's always going to be defined. So the only thing we have to do is find those points or those values of x where the derivative is 0. So to do that, what we're going to do is we're going to factor this function out. So we have a quadratic polynomial, so we can factor it, and then we have to multiply to -2, so we could do +2 and -1, because when we add them we get +1. So in that case our critical numbers are going to be x equals 1 and x equals -2. X equals 1 being the 0 in this expression, and -2 being the 0 in this expression. And then we're going to use those numbers to form a little table where we're going to have intervals, and we're going to use those points. So we start from -infinity and we go to -2. Our next interval will be from -2 to +1, and then we're going from 1 to +infinity. These are going to be our intervals, and the rationale behind it is we have these points, these critical points, x equals 1 and x equals -2, or numbers rather, and these are the point or the values of x where the derivative could change signs. So what we're going to do is we're going to choose test values in each interval, and we're going to plug those values back into the derivative, and we're going to find the signs. What happens is, since we chose all the values of x where the derivative can change signs, the derivative will have the exact same sign on the whole interval. So for example, if I choose -3, which lives in this interval, or 0 that lives in this interval, and 2 in this interval, whenever I find the sign of the derivative at this point, I'm finding the sign of the derivative on the whole interval. So we're going to call this our test values. And then we're going to plug those, and we're going to find the sign of the derivative. Now, we're not going to worry about the exact number, we're going to just worry about the sign. The reason being is because we are going to use that to determine whether the function is increasing or decreasing on that interval. Remember that when you have the sign of the derivative being positive, the function is increasing at that point, or the neighborhood of that point rather, and whenever you have the sign of the derivative being negative, then you have that in a neighborhood around that point the function is decreasing. So we're going to have a conclusion which is going to be either the function is increasing or decreasing. So for example, -3, and I factored my derivative already, so I can just choose it to plug my -3 into these two factors, and then look at the sign on each factor and then multiply it out. For example, if I plug -3 here, I want to have -3 plus 2, which is -1. And then if I plug it here, I'm going to have another negative number. And negative times negative, that's going to be positive. So that's telling you that your function here is increasing. Then whenever you plug 0, this term, x plus 2, would be positive, and then 0 minus 1 is negative. So the function is, the derivative is negative and the function is decreasing. I'm not going to be able to fit it all. And when you plug x equals to 2, here you get 4 and here you get 1. The product is positive. As I said, the values you obtain are not particularly important. The sign is what you're looking for. So what that's telling you, the function is going to be going from increasing to decreasing. So you're going to have a relative maximum at x equals negative 2. Then whenever you go in this interval, you're going to go from decreasing to increasing. So you're going to have a relative minimum at x equals 1. So right now you can already conclude that at x equals 1, and then the y coordinate will be f of 1. Here you don't plug it in the derivative. You're looking for the y coordinate of the point, so you plug it into f. When you do that, here you obtain 23/6 by plugging it directly into the function. Here you plug x equals 1, you get 1/3 plus a half minus 2 plus 5. And this is going to be a relative max. Oh, sorry, relative min. You're at x equals 1. I'm doing x equals negative 2. When it's x equals negative 2, you have f of negative 2 is equal to, and this is 25/3, and that is a relative max. 25/3. Okay, so we have then this information. Now we can plug it into our we can sketch the graph of this function. So we have a few points. For example, at x equals 0, we have the intercept at 5. Then whenever x is 1, we had 23/6, which is about 3.83, so almost 4, so say around here. And then 25/3 is going to be 8.33, so at negative 2, somewhere down here. And then we should plug a couple more points, for example, -3 and +2. Let me do that and let's find the values. So I went ahead and calculated the points and plugged them in, and then you see the function will do something like this. If I can connect the dots. So that will give you an idea of what the function is doing, and you'll see you have a relative max at x equals -2 and a relative min at x equals 1. So that's that for this one. Let me show you the graph of the function, or let me paste a graph of the function calculated or drawn with a computer software. So here it is. You can see this is the graph of the function drawn with a computer software, and you can see how at x equals -2 you have this relative max, and at x equals +1 you have a relative min, and here's your intercept, and these are the points that we have to plot. Notice one thing, however, even though this line looks like it's the x equals 0 line, it is really not. You have here 4, so it's 3.83 or close to that. Alright, well that's that guys, and so if you have any questions, please let me know. I will be glad to answer.